this is section 5-2, and I think this is like about day 2 for us because the last time we lectured, I'm pretty sure I was in 5-2. We just didn't deal with this. There was a lot in that section 5-2, and I wanted to separate it out. Okay, so we are going to be solving first order separable differential equations. All right, now here to start with, I do think I am going to like give you steps as distinct. Here's step 1, here's step 2, here's step 3, here's step 4. All right, so that's going to help you through this. Okay, but at the same time, I want you to conceptually understand what we're doing. And as we start this and as I do the first example, I'm going to refer back to things that we did. Because if you remember, I don't know, it was before Christmas. All right, I introduced you to a differential equation and we took a function and then wrote it in differential form. All right, okay, so that's going to play a part in helping you to understand how to now solve these type of equations. All right, now something just in general here, you are going to solve these and get a general solution. So you'll always solve it and have a general solution. Our general solutions are going to have a plus C in it. And then the problem is probably going to give you a point on the curve, some constraints, some conditions. And with that, then you're going to be able to solve and get a particular solution. So almost every time we solve one of these differential equations here, we're going to have 2 answers. All right. So let's in general just talk about our steps here. Okay. So in general, you're going to take whatever they give you and you are going to solve for dy. Okay, so that's the separable part. Okay, we're solving first order separable differential equations. So when I tell you to solve for dy, you are able to separate all the terms and get dy on one side and get everything else referring to your x's on the other side. You'll get everything with y on the left side, everything with x's on the right. And that means that it is separable. We can do that part. Okay, your second step is you're going to integrate both sides because we're going to have an equal sign. Okay, so we'll have our dy's and y's on the left. We'll have our dx's and x's on the right hand side. Okay, now let's throw in here later. We will add more steps. All right, but right now, these are your initial steps that we're going to do, okay? But later, we're going to add more steps at this point. All right, but until then, our third step is going to be you will have a general solution, okay? Because once I integrate both sides, I'm going to have a general solution. Okay, so there's our first part of our answer. All right, so then our fourth step is then we will plug in our given conditions or constraints, whatever you want to call it. Okay, you're going to plug in your given conditions. Let's be a little more specific that into the equation and solve for C. Because when we have this general solution, it's going to have a plus C in the answer, okay? And so then if I take my given conditions, I plug it in for everything except for that C, then I can solve for C, then I know what C is. And then once I know C, then I can rewrite the general solution as a particular solution. Okay, so we're going to have a general solution and a particular solution. And right now, it's going to be pretty straightforward, like 5 steps, all right? And then a little bit later, I am going to add more steps because we're going to do more complicated ones. All right, but we will start out with some pretty minor ones here. Okay, so if I were you, this right now to start you off, this is the 5 steps you need to memorize so that you can solve a differential equation. All right, and initially when we take a written exam, it's going to say solve the differential equation. So like, even if you don't recognize that you've got a differential equation, then the directions are going to lean you in that direction. Okay, So with that being said, let's take a look at, pull this back down. Let's take a look at one here. All right, let's suppose they tell you to solve. All right, and then you have something that looks like dy over dx is equal to 2x over an x squared minus 9, x squared minus 9. And then let's say given, here's your conditions or your constraints, things that they have given you, given the point 0, 4. Okay. All right, now our very first step says solve for dy. Okay, so this one's going to be a relatively easy one. If I want to solve this equation for dy, what am I going to do? I'm going to multiply both sides by dx. All right, so I'll go ahead and do that on this step so I don't have to rewrite. So I'm going to multiply by dx. I'm going to multiply by dx. That means the dx's are going to cross out on that left-hand side, which is what I want. So I'm solving for dy. Okay. So then it looks like dy is equal to 2x over x squared minus 9 is equal to dx. They're not equals. Okay, now this is where I want you to stop and think. Okay, look at this right here. All right, before Christmas, I just barely introduced a differential equation to you, right? And I gave you the function, the problems, gave you the function, and it told you to write it in differential form. Differential form. This should look familiar to you. Well, how did we come up with this? They gave us the original equation, function. We took the derivative and we set it right here. So that means this is a derivative. All right, it's a differential equation. This is a derivative. It's a first order derivative because all we did was find the first derivative. All right, and then we set it in dy equals derivative dx. Okay, so that's our differential equation because that's a derivative. All right, now stop and think about this. All right, how do you solve equations? You do the inverse operation, right? If you had x plus 3 equals 10, you would subtract 3 from both sides. You do the inverse operation. If I know this is a derivative, then to solve this equation, I have to do the inverse operation, which is integrate, which was the next, step 2, integrate both sides. Okay, so yes, I want you to memorize those steps, but at the same time, I want you to understand why we are integrating both sides. It's because that's a derivative. And if I want to solve an equation that's got a derivative in it, I have to do the inverse operation, which is integrate. Okay, now I am going to do this, and I'm going to put an integral here, and I'm going to put an integral there because I generally do it. Okay, that's a sad integral. I usually do that just so it saves me from having to rewrite there. Okay, but that is another step. I've integrated at that point. Okay, there is an imaginary 1 that's sitting right there, right? Because I'm just integrating dy. I'm integrating 1 dy. Okay, so when we integrate 1 with a dy on there, that gives us a y. So integrating this side is going to be relatively simple. Okay, now I've got to integrate this side. All right, and almost every time here, this is going to involve a u substitution. All right, so again, what do? We pick our u. I'm kind of leaning towards that denominator because if I take the derivative of x squared, I get 2x. So that's going to help me cross things out. So I'm going to let my u equal that whole denominator, x squared minus 9, take a derivative of both sides, du is equal to 2x dx. All right, go ahead, solve all the way down for dx. So du over 2x is equal to dx. Okay, so there's my u substitution. All right, then I'm going to come back up here and do I want to rewrite? I'm going to rewrite again. 2x over x squared minus 9 dx. All right, now let's do this. Okay, now I'm going to come up, and I'm just trying to, because I do this a certain way, I write my notes a certain way, so this is why I want it to look like this. All right, now I'm not doing an equal sign here. I did a little arrow here. I don't want to carry this y equals y equals y equals y equals all the way down, so that's why I did an arrow here. All right, now I'm going to integrate. Now let's do some replacing here. Okay, so my 2x is going to stay on the top. That x squared minus 9 is going to be my u. I'm going to replace dx with what it equals. So there's going to be a du over a 2x. All right, so this is good because we see now that 2x crosses out. Really nice right there, which then is going to leave me with, all right, now see here again, this y, don't forget that y is on this left-hand side. I'm just not going to bring it all the way down. I'm going to have an integral of 1 over u du. All right, and then we just learned last week how to integrate that. Natural log, right? Natural log absolute value of u. So natural log absolute value of u, and then plus c. And then I can plug my u back in. Natural log absolute value x squared minus 9 plus c. Okay, so now there is my general solution. But now in the past, like on yesterday's or Friday's homework assignment, what did we do? I let you just circled that. You were done. That was your general solution. All right, except there is a y here. So for this, when we're solving our differential equations, I really need to put that y there. All right, I need to put that y there so that this then is my general solution. All right, now why is it such a big deal? All right, well, it's a big deal because I'm going to come back up here. All right, let's move back up a little bit here. All right, they give me an ordered pair, right? Which here's x and here's y. So I need to actually see my y in my general solution so that I'll be able to plug things back in. All right, so there's my general solution with our plus c, which is step 3. Step 4 said plug in. So we're going to plug in that 0, 4. All right, so let's actually label here what we're doing. So we're plug in 0, 4. All right, into that general solution. So I'm going to write the general solution first. Y equals natural log absolute value x squared minus 9 plus c. All right, so I'm going to plug in x and y here. So that means my y is going to be a 4. Natural log absolute value 0 squared minus 9 plus c. All right, continuing here, absolute value of that negative 9. All right. How do I want to write this? Let's just go natural log of 9 here. So 4 equals natural log of 9, because it'd be a negative. I'm going to take the absolute value. It's going to give me a 9. All right. And now I'm going to subtract the natural log of 9 from both sides. So 4 minus natural log of 9 equals c. All right. Now I have a value for c. Okay. So now that I have a value for c, I can write my particular solution. So what I'm going to do is I'm going to take this general solution, and all I'm going to do is replace c. So I'm going to have y equals natural log, absolute value, x squared minus 9, plug in this great big long thing, all right, plus 4 minus natural log of 9. Okay, I did not say it was going to be pretty. Okay, so that's my particular solution. I have solved this differential equation now. I've solved it and got a general solution. Then I plugged the constraints back in. I found my c, and then now I can write my particular solution. Okay,